If you want to know everything about simplification of algebraic expression, then I want you to stick to the end of this video, because in this video, I'm going to be treating that in detail. AC Okocha is my name, and this is Just Academy, where we make you a mathematics genius. We are still in quadratic equation, but I need to take this topic because most of the things we are going to be seeing under this subtopic are things we have done in quadratic, in the part of quadratic that we have done. So simplification of algebraic expression. We are not done with quadratic. After this, I'm going to talk about evaluation of algebraic expressions, and then we will now go back to methods of solving quadratic equation, completing the square method, formula method, sum and product of root. And so there are still so many things we need to we need to do in quadratic, but let's take on this now. So when you are asked to simplify, you are asked to make something easier, make it simpler, simplify this algebraic expression. This is an expression, obviously, because there is an absence of what equal to. When equals to is missing in a mathematical statement, that statement is an expression. So this is an algebraic expression. So we're asked to simplify this, and this is a fraction. Why this is another fraction? When you have a fraction, two fractions being combined with minus sign, the operation is negative, minus. What do? You have to find the LCM. So the same thing is applicable here. So we have x plus 2 over x minus 2 minus x plus 3 over s minus 1. And what is the common denominator? What is the LCM? The LCM is s minus 2 times s minus 1. Because they have nothing in common, the LCM is multiplication of both. So this go here will give us this. This will times this. That is s minus 1 will be timesing s plus 2. Then this minus, look at it here. When this go into this 2, this will go cancel this. We are left with s minus 2. So s minus 2 will be timesing s plus 3. So we just expand in order to get our answer. And in expanding, we have that s will times s to give us what? S squared. S times plus 2 is what? 2x. 1 times x is what? Is minus x. And minus 1 times plus 2 will give us minus 2. Then minus, still put this in bracket. This will give us s squared. S times 3, 3s, minus 2 times s, minus 2s, minus 2 times 3, minus 6 over x minus 2 times s minus 1. So of course we'll have to open the bracket to have that s squared, this 2, this is plus 2s minus s will give me plus x, that is 1s minus 2. If you open this bracket, you have minus x, this 2, 3s minus 2s is 1s. 1s times minus will give me minus x, that is minus 1s. Minus times minus will give me plus 6 over what? X minus 2 times s minus 1. So what do? We conclude by saying that s squared minus s squared is 0. Of course, this will cancel this. X plus s minus s is also 0. So we are left with minus 2 plus 6. And minus 2 plus 6 will give us what? 4. So the answer is 4 over x minus 2 bracket s minus 1. This is the answer. Simplify as it is now. So this will cancel this because this is plus x minus s 0. Plus s squared minus s squared 0. Minus 2 plus 6 will give us plus 4 over this denominator. So it's already simplified. Let's see more. Now, look at example 2 and 3 here. For example 2, you see why I decided to treat this here? Because we're going to see a lot of factorization, difference of 2 square, all those stuff we have applied in quadratic, we have treated in quadratic, we are going to see them here. So now, if you look at this example 2 now, you see that the numerator is already difference of 2 square. So the numerator I can rewrite as x minus y times x plus y. over what is common in the denominator is 3. If 3 is outside, what will remain? S minus y. So if that is the case, this one can cancel this one. So we are left with what? X plus y over what? 3. And that is all. So you see, they only tested the knowledge of difference of two squares here. Now let's see example 3. For example 3, look at this now. We have, let me write it out first. 1 over x minus 2 plus 1 over x plus 2 plus 2x over s squared minus 4. Of course, if you have been following this class accordingly, you will know that these two are factor of this. In other words, this times this will give you this. When you multiply these two together, you get this. So the LCM of the whole of this denominator, the LCM here should be s squared minus 4. This s squared minus 4 simply means s minus 2 times s plus 2. So when s minus 2 go in here, what will remain is s plus 2. S plus 2 with times 1. That is 1 times s plus 2 plus, when this s plus 2 go in here, s minus 2 will remain. That is 1 times s minus 2. Then when this go in here, it will give you 1. 1 times 2, that is 2x. So you open the bracket to have that what? X plus 2 plus x minus 2 plus 2x over x squared minus 4. Are you getting it now? Well, we can actually simplify it. I will have even used this, prefer this, because this one is not yet simplified. But we know that this plus this is 2s. Plus 2 minus 2 is 0. Look at it. Plus 2 minus 2 is 0. S plus s, 2s. 2s plus 2s, 4s. So it's better we write it like this. Instead of this, let's use s minus 2, x plus 2. Stop there. So it's also simplified. Okay, we have more. Let's proceed. Look at example 4. Look at example 4. Now, for example 4, we are asked to simplify this. Let's see what happens here. Solution. If you look at example 4 carefully, you will notice that this is a full-fledged quadratic and this. Except you're a magician, we just need to factorize this and we need to factorize this in order to know what to do from there. So if we are to factorize this, we are going to have that s squared plus 5x plus 6. Then we are going to factorize this other one here, s squared plus 3s plus 2. So for this one, add to give you 5 times to give you 6. I believe 2 and 3 will work perfectly. 2 plus 3 is 5. 2 times 3 is 6. So that should work. S squared plus 2s plus 3s plus 6. What is common? X is outside, remaining s plus 2. What is common? Plus 3 is outside, remaining s plus 2. So here we have that what? X plus 2. What is remaining? S plus 3. So this is this. We'll do the same thing for this side. So here now, we're looking for two numbers, add to give us 3, times to give us 2. Of course, 2 and 1 will still work. 2 plus 1 is 3. 2 times 1 is 2. So we have s squared plus x, 1x plus 2x plus 2. So here, x is outside, we have x plus 1. Here, plus 2 is outside, we have s plus 1. Factor out what is common. S plus 1 is common outside. What will remain? S plus 2. So this is this. Therefore, in the place of this, we can now say 1 over x plus 2 times s plus 3 plus 1 over s plus 1 times s plus 2. So with this now, we can now see obviously that the LCM of 4, this is here common. So the LCM will be s plus 1, s plus 2, s plus 3. That is the LCM. We'll pick one of these common s plus 2. This here, this here. This is the LCM. So the whole of these two go into this 3. This will cancel this and this, remaining s plus 1. So here will give us 1 times s plus 1. Plus, when this go here, this will cancel this will cancel this, remaining s plus 3. So here will give us 1 times s plus 3. So if we expand, we have that x plus 1 plus x plus 3 over x plus 1 times s plus 2 times s plus 3. Of course, if you add this together, you will notice that we are going to get what? 2s plus 4 over x plus 1 times s plus 2 times s plus 3. And we can't stop there because something is common. 2 is outside. If 2 is coming out, we have s plus 2 remaining over s plus 1 times s plus 2 times s plus 3. And if that is the case, this will cancel this. So we are left equivalent to, not equal to, because it's not equation. We can say that there is no space. I will have written it under. We are now saying that the final answer will be 2 over what? S plus 1 times s plus 3. That is what we are saying here now. That is simplification of this one will give us 2 over s plus 1, s plus 3, because this will go away with this. Are you seeing it now? So, until you factorize this, you will never know what will come out. And you don't know the common value. So that you can see that is the knowledge of quadratic equation that is playing heavily here. But I want to show you more. There are more to show you. Look at example 5. Look at example 5. If you look at example 5 carefully, remember your antenna for difference of two squares will always be open, especially when you see squares. If you look at this numerator, difference of two squares is applicable. You look at denominator, difference of two squares is also applicable. I will show you. The numerator, see this as a value. See this bracket as a value. So if we apply difference of two squares here, we are going to get 2m minus u minus m minus 2u. That is the first bracket. Then we have 2m minus u plus m minus 2u. That is by difference of two square, direct application. Difference of two square. Then for the denominator, just bring out 5. If you bring out 5, we are left with what? We are left with m square minus u square, which is yet another difference of two square. But let's expand this and see what happens. So I have 2m minus u minus m minus times minus plus 2u. Then we have 2m minus u plus m minus 2u over. This is not happening in my Bible. Okay, so now here under for denominator we have 5 brackets m minus u. We apply difference of two square yet again, m plus u. That is difference of two square. If you have been following my class, these things are simple now. We've done all that. So 2m minus m, 2m minus 1m is m. Minus 1u plus 2u will be plus u times 2m plus 1m is what? 3m. Minus u minus 2u is minus 3u, obviously. So we have 5 times m minus u, m plus u. Of course, without wasting time, we know that this one will go with this one. But inside this one here, 3 is common. So if 3 is outside, what will remain? M minus u over 5 brackets m minus u. So yet again, this will go with this. So the final answer is what? 3 over what? Over 5. That is the answer. 3 over 5. Factorize. Factorize. Are you following? Okay. Now, let me show you more. I have more to show you. Look at example 6. Look at example 6. It's a game of difference of two square and all that. Look at example 6. If you look at example 6 carefully, you will yet again see difference of two square. So for this place, we repeat it as x minus 7 over this down one. Of course, is difference of two square. Of course, you know now, which will give us s minus 3 times s plus 3. That is the denominator there, times the numerator here. S is outside. What will remain? It will remain s minus 3. For the denominator here is difference of two square, x minus 7 times s plus 7. These are things we have done. It's just that it's this one now. I'm showing you the simplification now. Okay, so since it's multiplication, we can cancel out straight, or we can just show that this is s minus 7 times x. You can even write the s in front. You can write it like this. Anywhere, can be anywhere. All over s minus 3 times s plus 3 times s minus 7 times s plus 7. So we'll just cancel out. This will cancel this, and this will cancel this. There is nothing to cancel again. So we are left with x over x plus 3 bracket s plus 7. And we'll stop here. There's nothing to do again. So that is example 6. That brings me to example 7. Like I said, I have, you can see example. All these things I'm showing you are exam questions. They are exam questions. Look at example 7. The same thing is applicable. We have difference of two square, we have perfect square. Look at it. This up now, s square minus y square is difference of two square. If we apply difference of two square there, we are going to get what? That x minus y will times what? S plus y. That is the meaning of this. Over this one means we double the bracket. That is s plus y times s plus y, of course. Divide by, let's see, retain divide for now. X minus y times x minus y. Not s minus s plus, so you just double the bracket. This one, what is common? 3 is outside, remaining s plus y. Then let's convert this to multiplication. We have s minus y times s plus y over s plus y times s plus y times, when here is times, this will come up, 3 times s plus y over x minus y times x minus y. So we'll cancel out, since this is times here. This can go with this. This can go with this. Even this can go with what? This. So at the end of the day, we are left with 3 over what? X minus y. That is the answer. And that is option C there, as you can see. 3 over s minus y. Okay. I still want to show you 2 more. Let me show you 2 more. I have a lot of examples here. Please make sure you watch this sequel to this. It's up to example 15, but I'm stopping this video in example 9. Then I will continue from example 10. From example 10 to around 14, 15, they are advanced algebra. So you need to see that video and enjoy it. Okay, look at this now. Example 8. Of course, yet again, we have difference of 2. Of course, we know that this difference of 2 square. We can factor s out here, but we may need to factorize this first in order to know. But we can do it here straight away. Add to give you minus 4 times to give you plus 4. That is minus 2 minus 2. So minus 2 minus 2. So the answer is actually going to be s minus 2, s minus 2. That is it. S minus 2, s minus 2. There is nothing remaining again. But for the sake of understanding, let me put it that way. We can as well show it one after the other. But this one here now, like I said, x squared minus 4x plus 4. Factorize this one alone. You have x squared minus 2x minus 2x plus 4. I've already told you the answer before, but I'm just showing you. So x is outside, you have x minus 2. Minus 2 comes out, you have x minus 2. So that means that x minus 2 will times s minus 2 to give you this. Are you following? So if you apply here now, I was only using it to show you. We are now saying that for this s squared minus 4, that is difference of 2 square of s minus 2, s plus 2 over x is outside, what will remain there? S plus 1 divide by, we now know that this is s minus 2 times s minus 2 over s plus 1. Can you see that now? So we say that s minus 2 times s plus 2 over s bracket s plus 1 times s plus 1 over what? S minus 2 times s minus 2. Of course, we'll cancel out. S minus 2 cancel s minus 2. S plus 1 cancel s plus 1. Nothing is cancelling again. This cannot cancel this, of course. So we leave it as s plus 2 over s bracket s minus 2. That is the answer. We'll leave it like that. That is the only thing that can cancel. There is no other thing. We can't cancel this and this. So that is it for that one. Okay, let's close this class with this example 9. Let's close with example 9. This example 9, there is something interesting about this question. If you look at this question very well, there is something I want to teach you. But because of time factor, I would have loved to show you this in 2 ways. And that is without analyzing a question properly. If you rush in, you are likely to make mistake or get stuck in the process. If you look at this, the first thing that will come to mind is just go and find the LCM. Or you see, this is difference of 2 square. Yes, that is true. This and this are factor of this. That is not true. This and this are not factor of this. And I will tell you why. Because if I leave you without explaining that, what will come to your mind or mind of most students is to go and find the LCM and say that this is the LCM of the 3. No, this time this cannot give you this. And why is that? Notice that this one, this is s plus y. X start followed by y. X start followed by y. Difference of 2 square. S square, y square, not y square, s square. This one is y is starting followed by x. Assuming s is starting followed by y, then it will correspond to this. So your first work is to make this one to look like this two. Now watch. So I will say that y over s plus y plus yx over x minus y. Now watch this now. The minus is coming here because of this, but let me show you why. 2s over y, then rewrite this as minus s squared minus y plus y squared. Just rearrange this. I'm just showing you so that you will not say, how come you just came and put minus here? No, I want to explain. That is what I'm explaining. Y over s plus y plus x over x minus y plus. Now, if you factor this minus out, this is still 2x plus y over. If you factor this minus out here, down here, you have s squared minus y squared. Because minus times this will give you this. Minus times this one will give you plus. Are you with me? Now, because in fraction, minus with denominator also affect the numerator. And minus with the denominator, because fraction means they are together. So in other words, this minus can be assumed to be here. Or this minus can go ahead to times this plus. So that you have y over s plus y plus x over s minus y minus now 2sy over x squared minus y squared. All this here I'm explaining is just to show you why I'm changing this place to minus. But I will have just written this from here straight to this place, but where I'm still showing you. So it's practice. Now, notice that the minus is here now. This minus is what is the right thing that should be here now. Notice that this is now difference of 2 square. So the LCM of this 3 now means s plus y, x minus y. Because this time this will give you this. So this going to this will give you this times y. That is y times x minus y. Plus this going to this will give you this. That is x times x plus y. Minus this going to this 1. Because this time this is this. So you have 1 times this. We have 2xy. So we'll just open the bracket to get our answer. We'll have xy, s times y times s, sy, 1 times minus y, minus y square, s times s square, s times y, sy, minus 2sy over s plus y times s minus y. Now notice that this is s square, sy plus sy, 2sy. 2sy minus 2sy, 0. So this and this, sy plus sy, 2sy minus 2sy, 0. We are left with this. And this one here means it can start with x, s square minus y square over this. And this one down is the same thing now as up. It's the same thing. This one down, you know, is the same thing as s square minus y square. So this can cancel this. The answer is just 1. The answer is 1. The answer is 1. That is it for this one. Is that taken? So it's all about being versatile in this. So I want you to watch these videos over again so that you understand it properly. But let me say this. This is example 9. There is a square. There is example 10, 11, 12, 13, and 14. And those ones are more sophisticated than what you have seen. So don't miss those ones. Don't miss the next class. Very, very important. Please remember, if you want me or any of our teachers to teach you one-on-one basis, you need someone to explain these things in detail for you. It can be any topic at all in maths. It can be calculus, it can be geometry, it can be trigonometry, it can be algebra, it can be anything. Just send me a message via the WhatsApp contact showing on the screen. Tell me exactly what you want. We are available to teach you one-on-one. And then if you know you are not following us on our social media handle, please do that. Facebook, YouTube is the same handle, just Academy Mathematics. And more importantly, make sure you share our videos. When you share the videos, more people will see it. More people will benefit. More people will know that a channel like this exists where you can come and learn maths in detail. Our goal is to teach mathematics in detail, not just pick one question and solve and run away, no, but treat these things in detail to help you learn maths properly. And we're taking it topically. After quadratic equation now, I'll move to simultaneous, I'll move to sequence and series, I'll move to just like that until we cover the entire maths. Even if it's going to take us 2 years, 3 years, 4 years to do so, I'm going to do it. But time will come whereby anything you want in maths, you just come to the channel, go, you'll see it arranged topically and in detail. So encourage us by sharing our video. Thank you. See you in our next class as we continue with example 10.